Hi everyone, Ari Mahpour here, and today we're going to look at creating continuous integration pipelines using the Raspberry Pi Pico device and MicroPython. In the previous tutorial, we looked at how to run and flash a MicroPython-based device, in this case the Raspberry Pi Pico, and run a few commands using their interpretive shell. In this tutorial, we're going to look at how to automate all of that both on the command line and integrate it into your CI pipelines using GitLab CI. So come join me and let's get started. So before we get started with the tutorial on how to automate a lot of the MicroPython stuff that we talked about in the previous article and the previous tutorial, I just want to give a quick introduction to what we're doing here. So if you're following along with the tutorials themselves, I have an article up here called Automating MicroPython Development Testing Using Continuous Integration. If you're not familiar with the predecessor to this article, the precursor, it's called Getting Started with MicroPython and the Raspberry Pi Pico. And that basically shows you how to set up a Raspberry Pi Pico device / MicroPython operating system onto the device and run some very, very basic examples. The examples that we went through over here were like blinking LEDs, but also most importantly is determining what is the device, the target device we're running on, and what is the operating system. In this case, we saw by using the interpretive shell, it says that our operating system is MicroPython and that we were on a Raspberry Pi Pico, the RP2040 chip. That's an important piece that we're going to use to validate our architecture moving forward. So just giving you a little bit of a background on that. Another thing that we're going to be using in this tutorial is a utility that comes from the MicroPython library. This is before the MicroPython gets generated into an operating system. All the source code can be found on GitHub. Inside that source code repository, there is a tools folder, and inside that folder is a script called pyboard.py. This script is not used on the actual device, but it's used on your computer. And what the script does, if you go to their documentation for the MicroPython, the official documentation of MicroPython, this is basically a utility that'll allow us to run an interpretive shell directly onto the target device without actually opening up Terraterm or PuTTY, things like that we did in the previous tutorial. So this helps us automate some things. It also allows us, gives us a little bit more flexibility into copying files and listing files on our device. So we can run some automated utility to do that. In addition, we can also import this as a library for a Python script that we write ourselves. And we'll see that coming up in this tutorial, not only just a regular Python script, but Python tests to automate and validate our hardware and anything that we're running. So we'll dive into examples on writing code, writing CI scripts, and running all of this in an automated fashion. So we're going to get started here, and what I'm going to do is follow along through the CI script, because the CI script kind of goes in order, increases in complexity as we start from beginning all the way get to the end. So I want to first demonstrate how to run a basic command line test. For right now, let's skip this Docker build environment. We'll get to this in a minute. And that's going to be critical for setting up our CI environment. First, let's do just a very, very basic command line test. You see, I have a command laid out right here. This is for the pyboard.py that we talked about. This is the script that we were able to pull from the MicroPython repository. So let's go here. Let's run this command. And over here, I don't even specify a device because the default is the TTY ACM0, which is what I have right now showing up as my device. If you're doing this on Windows, it'll be a certain COM port. You'll have to specify that directly in your command. So I'm going to go ahead and run this command. And what this is doing is running the same thing that we had in the interpretive shell using PuTTY or Terraterm in our last tutorial. So go ahead and enter. And here we have the name of the operating system, MicroPython, and the target device is the RP2040 chip. Now, I didn't have to open up any interpretive shell. This literally just ran from my command line in my Linux machine and then grabbed the information directly off of the device. So again, no serial communication necessary to open up in like a PuTTY or a Teraterm, which is really nice. But let's take this one step further. So now what we'll do is we'll take this and incorporate a command line function into continuous integration. So what I've done here is I've encapsulated a Docker file into the CI repo that I have over here. So it's very, very simple. It's just a pip install of all my dependencies that I need. I need PyTest, I need PySerial. I'm using just a very, very lightweight Python container, which is Alpine. Grabbing the latest. I'm downloading that pyboard.py and putting it in a root directory called app. I'm copying an extra file that I've written, listports.py. This is basically just a quick utility I've written to grab the port number. This works in Windows and Linux. This grabs the port number for if you specify a vendor ID and product ID, PID and VID. And then it'll return either the dev /dev / whatever it is, TTY, yada, yada, yada. That's a lookup for that vendor ID and product ID, or it'll return a COM port if you're in Windows. So that I can now, if I go into my README, I can run this whole environment that I've built with Docker either locally or I can run it in CI. Best way to validate that your CI is going to work remotely is always to test it locally. So I like to run all my code locally within a Docker container first. That's entirely up to you how you want to configure it, and how you want to test. But I like doing this rather than just running tests directly from the command line. So I'm going to run this Docker command. Let's run through it really, really quickly. I'm offering privileged permissions to my Docker container. This is basically giving it full access to all of my hardware devices. You may not want to do that long term. This is just a quick way to get up and running. You might just want to pass the actual device through. You can do that. That's a little bit out of the scope of this tutorial. I'm passing the volume. So I'm passing this folder that I'm currently in, which is my repository, into a location called /code. My work directory is automatically going to CD into that /code. The vid and PID, I've set that up over here as environment variables, and then I'm going to run that Docker container that I've built in GitLab itself. And so, or I can build it locally first if I want, and then shell, I'm going to run a shell. So I go here, run. Okay, so now we're in the Docker container. We're in the code directory, and you can see everything here that's actually in my repository is here. So if I go into my CI script and I want to now run, so I'm pretending as if I'm running this on GitLab itself. So I'm going to go set this environment variable. So this is going to grab the target port based on the vid and PID. And now I'm going to run this command. And here we go. This is using the command line option for running the getting the sys implementation. So I've just ran the tool using the command line feature within a Docker container. So now that we've demonstrated how to run the command line tool, I want to demonstrate how to import this actual script that came from MicroPython and use it within a Python script itself. Before we do that, let's just run the python-c command, which is essentially saying, run the following code in a Python interpretive shell. So if I export this, get my target port again, and I run this command, this will basically say, this will run code, and I don't recommend doing this. This is really just for demonstration only. We'll have to write some code in a little bit, But this basically demonstrates the ability to run Python code on the fly. So it's here, and it returns with the same information. Notice the carriage return over here. This is basically it's using the library, going into the MicroPython operating system, going to the Raspberry Pi Pico device, grabbing that information, and then printing it for me. Now, let's take this to the next step. Let's actually put this into a script itself. So I've written a script called Raspberry Pi Pico check. What this is doing is I've got a few functions, but basically I'm setting up my environment over here with just grabbing the COM port. Again, I've got the vendor ID and the product ID. I don't know what COM port it's on. I don't want to manually input it. So I'm using this utility to basically look it up for me. And this assumes that you have only one Pico device hooked up to your computer. If you have multiple, then it can get a little complicated because it doesn't know because they have the same vendor and product. So I first set up my module, and then what I do is I run the same code we just ran down here, but I've added it into a Python script. So I first enter into the raw REPL shell, which is basically saying hook up into the MicroPython based target device, so the Raspberry Pi Pico device, and get me an interpretive shell. Then execute the following functions. So I'm going to execute first import sys, which I've done in my code itself. And then I'm going to run that sys.implementation and grab different pieces of it. So I'm going to check to see what the name is, check to see what the machine is, and check to see what the version of the Raspberry Pi of the MicroPython operating system. So, and I'm going to run these as assertions, and then I'm going to exit out of it. So I'm essentially running a test without running any type of testing framework. So if we go ahead and run this, and again, all of the information, all of the demonstration and the details that can be found in this tutorial that I've written over here, automating MicroPython development, testing using continuous integration. So if I go ahead and run this code, let's see what happens. So I'm going to go back to my CI script, and I'm going to run this script here. And it returns with this information, and none of the assertions gave me an error. So if I go to my RPi Pico check script and I want to modify the version, so let's say I've reflashed MicroPython onto my Raspberry Pi Pico device, and I now have 1.19.2. So I want to update my test scripts to validate that. So if I go here and I run this script, oh, but turns out I'm using an old version of my Raspberry Pi Pico MicroPython instance or another device that I haven't flashed. And so when I run this script, it says, hey, wait a second, you're not using 1.19.2. So let's go back just to validate that. And as you can see over here, it says, oh yeah, the assertions did not pick up, meaning that everything looks good. So let's take this one more step forward before we jump into the CI side. I want to now run that as a PyTest. PyTest framework, you've seen in a lot of my tutorials, I use PyTest for pretty much anything. It's really basic, really easy to get started, not terribly sophisticated, but it gets the job done for most basic examples. So I've folded this, which you see over here, into an official PyTest. It's called test_rpi Pico. And again, you can follow along in the tutorial that I have over here. I've listed out all the details, pointed to the repository, everything like that. So let's dive in. I've set up my module just like before, and I've created this lookup function, which does the execution. But what I'm doing now is when I run the assertions, PyTest will let me know that it's passed or failed. So if I run this, in this case, the device is 1.19.1 and everything passed. I have that one test that passed. So let's say I change this to 1.19.2 but I've kept the same device. I haven't flashed anything. I run the same test. Oh, it failed. It says, hey, wait a second. When we queried the device, we got a version of 1.19.1, but you're expecting 1.19.2. So that's not going to fly. Okay, so we've got all of that going. Fix my test. Now, let's go to the actual GitLab CI script and GitLab itself. So if I go to the pipelines, or if you go look at the repository first, you go to the left-hand side, CI/CD pipelines. You'll see I've recently run a pipeline over here. And what this is doing is it's running all of those different scripts that I showed you, the command line test, running PyBoard import from the command line itself, that Python-C, and then running that PyBoard, the PyTest script that we wrote, the assertions without PyTest, and then the PyTest assertions-based test as well. So all four of these. And what will happen is this will run sequentially. So if I exit out of here, and I've made a slight change to my README, so I'm going to commit this, README, and I'm going to push. And so what's going to happen is you'll see a pipeline eventually kicking off here, which we'll get to in a minute. But I'm going to run through it. If you see over here, it's paused. This is going to run on my machine, and it's going to run through the same test. In the meantime, let's just take a quick look at the tests themselves. So this, again, this is not an official test. This is just running a command line, and if it failed, it would tell me that it failed. This ran that command line function through the pyboard.py, and this gave us the system implementation. The import command that we talked about, the Python-C, that's the same thing. Again, this is running fully automated, fully autonomous. Every single time I push my code, it'll run these onto the device. So I ran that command. That clearly didn't fail, so I'm ready to move on. Now we get a little bit more sophisticated, and we run that actual script. That script, again, did not fail with an assertion, and it passed through. It gave me, again, the information and checked everything. Now, finally, I run the PyTest, which is my favorite part, because it'll give me an actual test report, which then GitLab parses. So over here, it set up my test. It ran the test. One passed. We're, again, checking for the name, the version, the machine type, and then it passes. So if I go back to my actual pipelines, and I go to this pipeline here, and you go to tests, and this was the PyTest itself that we looked at. It'll tell you it ran in 63 milliseconds, and that passed over there. Now, if you look over here, you'll see that I do have this guy just ran on my machine, and then the next guy will execute. And this is loading up the Docker container. Now, just one thing to mention about the Docker container, I'm running all of these tests not in a shell-based command line test, but I'm running this in a Docker container. So my physical Linux machine is opening up a Docker container, running as privileged, and driving tests in and out of that container. This allows me to create a completely encapsulated environment. This allows me to say to a user, hey, go run this Docker container on your machine or on your Raspberry Pi or on whatever you're running, and run these tests with this target device. So this concludes the full walkthrough of getting MicroPython automated in your CI system. In this specific case, we ran MicroPython on a Raspberry Pi Pico device, hooked up to my Linux desktop machine as a GitLab runner using GitLab CI. So today we looked at how to create continuous integration pipelines for a MicroPython enabled device, in this particular case, a Raspberry Pi Pico. We learned how to run automated scripts using the command line and then integrate those into PyTests, and finally drop them into CI pipelines using GitLab CI. If you enjoyed this video tutorial, please check out the rest of the tutorials and videos in this channel. Definitely take a look at the article that pairs with this video, the rest of the articles, and please, if you enjoyed this video, hit the like and subscribe button. Thanks for watching. you.